Hey everyone, it's Shahid back again with another video here, which will be a continuation of the first video where we went over the basics of 3D object visualization. So in this video, I'm going to go over the rules that govern the keyhole section, and by doing so, I'll also go a little bit more in depth in terms of now manipulating the 3D objects that are given to us in every keyhole question. So without further ado, let's get into it. So this is a general overview of what I'm going to be talking about. So rules 1, 2, 3, and 4 are the official rules, and rule 5 is just something I added in there because I strongly believe in it, but I'll discuss it later on in the video. Okay, so rule number 1, guys, the object and option choices are drawn to the same scale. This means that for any given option choice to be correct, they must provide a perfect fit for the 3D object. Now, as with most things academic, I don't know about you guys, but for me, things always made more sense when I had a visual to go with it. So I went ahead and prepared some for you guys using the 3D simulator. So let's head on over there. Alright, so this is a simple model I've created for this example, and I also created the apertures for the object's corresponding top, front, and end views. And here they are. Now let's actually go through every one of these, and let's start with the front view because for me that's the most natural one to start with given this 3D object. Alright, so this is the keyhole for the front and back view, and this is how the object would pass through it. As you can see, just like that. And this is the keyhole for the bottom and top view, and this is how it would insert. And finally, this is the keyhole for the two side views, and this is how the object would pass through. As you can see, it's a perfect fit. Okay, now here's a situation where rule 1 really comes into play. So as you can see, I've created two keyholes, both of which are actually the right shape, but one is bigger than the other. So let's see what happens when we try to move both objects through at the same time. I'll do that one more time. And you should have seen that the bigger keyhole was not a perfect fit for the 3D object. There were spaces around the figure. Now if you guys missed that, we can look at it from the other side as well. So doing it once more slowly, you'll see that the correct size aperture has no spaces when the object is passed through. But the bigger aperture, the bigger keyhole, you can see that there are spaces between the keyhole and the object itself. This violates rule number 1, and therefore we can conclude that the keyhole on the right is incorrect and cannot be an answer. Alright, time to move to rule number 2, which states that the 3D object must completely pass through the option choice. Now, we actually saw this rule in play with the previous example when I was moving the objects back and forth through the various keyholes, but let me show you guys a situation where this doesn't always happen. So you guys probably remember this figure from the first video. It's more irregular compared to the simple example we just went through for rule 1, but this one shows rule number 2 perfectly. So this is a keyhole I've made for the front and back views, and as you can see, the object fits perfectly through, and it can pass all the way without any interferences, like so. Now let's look at a situation where the object can begin to pass but can't pass through completely. So as I start to bring this object through, you can see that the first part can go through, even the second part can go through, but then this third part can't because it's obstructed. Let's have a look from the other side of the keyhole for a better angle. So let's watch what happens when I bring the object through the keyhole. So as you can see, the first part of the object comes through unobstructed, but there is no way the object can fully pass through since the keyhole doesn't account for the tall extension on top of the base, so it just stops here. And given that rule number 2 states that the 3D object must completely pass through the option choice, we know that this particular keyhole will never be the correct answer. Alright, time for rule number 3, guys, and this is a cool one. So it states that the 3D object given can be rotated in any way whatsoever before entering a given keyhole. But once you begin mentally inserting the object through, you can no longer rotate the object. Now, even though the rules say that it can be rotated in any way, this is usually somewhat false, because if you think about it, there's way too many possibilities of a keyhole shape if they let us rotate the object arbitrarily. What they really mean is that the object can be rotated in increments of 90 degrees in the x, y, z coordinates. Alright, let's add some visuals to this. So let's say the blue object is the one we're given in the question. What do you guys think I'd have to do with the blue object to make it look like the green one? I'll give you guys a second to think about it. If you said, well, we'd have to rotate the blue figure 90 degrees counterclockwise along the x-axis with a plane of rotation in the YZ plane, you'd be right. But chances are not a lot of you guys would have said that. Like I told you guys before, I'm kind of nerdy, so I like to get technical, but for the most part, none of us really think of the plane or the axis of rotation when we think about this. We just know how we can get from one image to the other. Our mind just does the work for us. So, doing this rotation essentially gives us our top and bottom views. Now, if you had trouble understanding that, just mentally try to do it yourself and you'll see what I mean. Okay, so what if we want to make the blue figure look like the red one? Well, if you want to test yourself with the technical language, pause the video here, come up with an answer, and play it back. But pretty much you'd have to rotate the blue figure 90 degrees clockwise along the z-axis with a plane of rotation in the xy plane. Now you may think, there's a lot of possibilities for how you can rotate the object, even with the 90 degree increment restriction. But if you actually think about it, all the different rotational possibilities can only really lead to one of three keyhole outlines, and they're the ones I've shown here. This is why we only ever concern ourselves with the top, the front, and the side views. If you want to prove this to yourself, just try any combination of rotations and imagine what the corresponding keyhole would look like. You'll see that it'll be one of the three I've shown here. And that's exactly where rule number 3 is getting at. I made it sound pretty technical, but honestly, once you start doing a few of these questions, you'll see how simple the concept really is. Okay, time for rule number 4, and this is a very, very important one. Let's take a look again at our trusty example that we keep seeing. So this time I've duplicated the figure a couple times and I've made some changes. I'll give you guys a few seconds to see if you can spot out the differences. Alright, so if you were able to spot anything, you're probably a liar because the changes I made actually can't be seen. Now, we didn't really talk about it before, but we actually made a few assumptions concerning the surfaces that we can't see. For one, we assumed that the face colored in red here was continuous and that it ran all along the edges of the central extension. Similarly, we assumed that the surface colored in blue here was also continuous and that it ran towards the back of the figure with no new irregularities. These were reasonable assumptions that we made, and they actually must be made for us to be able to answer the question. Now, if I rotate these objects so that we can see the back sides, the hidden geometries that I made earlier become apparent. So rule number 4 simply states that such irregularities will not be present, and we can assume the object is continuous based on the initial view we are given. Alright, last but not least, everyone writing the PAT has to remember to not get caught up with any one question. It doesn't even have to be just for the keyhole section. As a general rule, I like to spend no more than a minute on each keyhole question. But, some questions are easier than others and some take much more time, and I totally get that. Also, it's not like you guys will time every question you do during the DAT. That's just not really realistic. But all I suggested is if you notice that a particular question is giving you a hard time and that you've been struggling with it for a while, trust your gut, choose an answer, mark it, move on, and come back to it only if time permits. And with that, we are done. So I hope this video was helpful in expanding your understanding of 3D objects as well as the rules that govern the keyhole section of the PAT. Make sure to watch the next video where I'll actually go over an excellent approach that all of you guys can use to do extremely well on this section. Till then, take care and see you next time.